Hi everyone, and thank you very much for watching this live event, lesson 67 of the Java Fundamentals stream, and we are going to discuss the last chapter that's relevant for your OCP exam using JDBC, like vanilla JDBC, which is something you won't actually see a lot in real-world examples in production-ready applications nowadays because it's pretty old, and usually we do use something over that, something that makes your life easier when writing code that connects to a database, at least some templating tools that use JDBC in behind the scenes, but you don't actually use JDBC vanilla a lot nowadays. But you still need to learn that for your, first of all, for your OCP exam, and secondly, just to know what's behind those tools that you use, and that's relevant from my point of view as well. And we will discuss this today and probably the next lesson as well, because as you will see, there are quite some things to discuss. They are interesting, so stay tuned and let's start our discussion with, of course, an example and see how you can connect your database step by step if you want to learn how to do that. This is the video you need to start watching. As usual, if you're watching the event live, you can send me questions in the live chat, so I have an eye on the live chat. And if you're watching the event recorded, you can still ask me questions in the comment section, or you can find me on Twitter and on LinkedIn, and you can follow me there as well. And of course, that's something you would like to do because you will see something, the things I share, which might be articles or posts or things of interest. So do that. And follow me on LinkedIn and Twitter as well, not only on YouTube. So with that being said, let's get started, and I will share you my screen as usual. So you should now be able to see my screen, and I didn't create yet a project because the first thing I'd like to do is introducing you build tool that I will use today. And the reason why I use a build tool is that the projects we are working on today and for the next lesson that use JDBC, they will need a dependency. And of course, you can add a dependency on a plain Java project as well, but that's a little bit more difficult and that involves a little bit more things to do. And we usually don't do that today. We are usually using something to help us with the dependencies, and I found that this as a good opportunity to show you how to use such a build tool to get use of your dependencies. This is something fundamental from my point of view, so it's a good choice to discuss this subject in a fundamental stream. And of course, the tool that I will work with today, which is Maven, it does a lot more things than only dealing with dependencies, so it really does a lot more things that I will show you today, but we will discuss all those things, all those other things in a different lesson, of course, because yeah, we don't have to do that in a Java Fundamentals session. So I just want to introduce you Maven today. And that's a good opportunity to introduce you Maven with this example of using JDBC, because we will need some dependencies. So you will, with this, also learn how to use a build tool to manage your dependencies, and we will use Maven for this. So because of that, and because of the fact that we have many things that are new, I didn't even create a project for now today. I will just create it together with you, so you can see how we create a Maven project and the structure of your Maven project. And then you will see whatever we need and why we need that, and we will get into the writing our code to work with a database and learn which are the basic interfaces you need to know from the Java SQL package in the JDK. And those interfaces and the way you work with them, again, are mostly relevant for your OCP exam. Maven is not there, Maven is not in the OCP exam, but it will be very helpful for us to use it to manage the dependencies of our projects that use JDBC. And of course, it's a fundamental thing that you should know as a Java developer anyway, so it won't hurt you if you learn how to create a Maven project and deal with your dependencies. So that will be really helpful for you, not for the OCP exam, but rather for the production ready applications you will work on. And yeah, first of all, what you need. So when we work with a database, now we discuss about connecting to a SQL database, and you have plenty of technologies you can choose out there from, but I will use in my examples MySQL. This is irrelevant for the Java implementation because what I will show you is the way you work with any kind of SQL implementation with Java. You can use MySQL, but you can use some other technology like Postgres, for example, Oracle, MS SQL. If you want to use something else, just know that you will write a very similar, like the Java code will be the same actually, and of course you might have differences in your SQL queries, but the Java code will be the same. I will just tell you what the differences would be along with our examples. But I will use MySQL because, for example, it's very light, very easy to install, and you can use it very well with theoretical examples. So that's why I'm using MySQL. If you want to implement these examples with me, you'll have to download yourself first of all a MySQL server, and to do that I usually let me show you, actually it's better this way. So you usually just search for XAMPP download, and you can download. This is one alternative. It's not the only one you can use, but this is from my perspective the easiest way to get a MySQL server. So you just go here on the Apache Friends org and you download your XAMPP for your operating system and you install it. And once you do that, you will have access to a XAMPP control panel, and that will allow you start a MySQL server. So this is how the XAMPP control panel looks like. And you see here, this is green, so it means that I have already started from my MySQL server, probably from another example I've worked with. But first of all, you will get it this way, where nothing is started. And then you can press the start button here just to start your MySQL server. And by default, your MySQL server is configured to start on port 3306. So this is the default port for MySQL. Well, that will help you with creating any kind of simple example where your Java application uses a database. So I love using MySQL and installing XAMPP on my test PCs where I do trainings and so on, because it's very simple. I immediately install on MySQL server, and then I can start it, and then I can work with it. Now the second thing you need to install to be able to test your test your application by seeing the data you have in a database, and to manipulate your database, to manage its structure and so on, you need also a client for your database. If you install MySQL, probably the best client you could install is MySQL Workbench. So MySQL Workbench is again an app that you will find free. You just have to search on it, or search for it on Google, and you will find it free, and you can install it. And then you can anytime create a connection for your local database. So you just create a connection from here to your local host on the same port you opened MySQL on, which is 3306 by default, and you use the username. If you didn't set up something special yourself, then you will get username root without a password, and you can use that to connect your local machine. And for your examples, if this is a database management system you only use for examples, then you can just leave it like it is. You don't need to have it secured somehow. Of course, that's not the case for a production-ready application where you cannot use the super user for working with the database, and where you need to have some properly configured users, but that's not a Java developer job, so I will skip that. And for your examples, you just install it as is, and you will be able to use it, and you don't have any problems. So you can just connect with root without a password if you didn't set up something custom yourself, and then you can, I cannot create it again because I have already created it. You can anytime just log in here, and what you see is that I connected to my local database management system, the one that you have seen me just starting it previously. And what you see on your left side here is your databases. So these are your databases. I will show you how to create a new database with our first example. But first of all, you need to make sure, if you want to recreate these examples with me, you have to make sure that you install a MySQL server, or if you have something, if you wish to use something else, you can use some other technology. From the Java point of view, it will be the same, but you need to know how to work with it. So you need to, if you say choose, for example, Postgres, you need to know how to install your Postgres server, and you need to use a specific client for Postgres as well. It's your duty. I will use, for my example, MySQL. You can decide to go with my choice, but you can as well choose whatever fits you better. So if you want to use another SQL technology, do that. It won't be a problem from the Java point of view. So if you wish to go with me and use MySQL, do install a MySQL server, and then MySQL Workbench, for example, to work with the databases and see the data and manage your databases, and do the things that we will do together, and you will see me doing with this example. So that's the prerequisites. That's what you need. So once you've done that, you have access to a database. Now let's create our Java project and understand what we need in order to connect to a specific database we have. So I will create my Maven project to be able to download some dependencies. And in IntelliJ you can do this by choosing new project, and then you have Maven here that you can choose. If you have a different ID, you can choose Maven as well. The majority of the IDEs today support Maven and Gradle, which are the mostly used build tools nowadays, so you can choose either one of them. My examples will be with Maven, and if you didn't use a build tool yet, I would advise you start with Maven and then go to Gradle, and you will see that there are very small differences between them in terms of what you can do. So yeah, you will be able to use both of them if you'd like. If you learn one of them, then going to use the other, it won't be a difficult job to do. So I will choose Maven here, and you can do that again if you have Eclipse, or if you have NetBeans, or if you use something else. Then you should be able to create a Maven project without a problem and have a similar options in your project, in your new project option. And then you go to next, and I have to name my project. I will just say just Java Fundamentals E67, the way I've named all my projects up to now, and say finish. Just replace this window. So let's take a look to see how our Maven project looks like. You will see that's a very similar project to just a normal plain vanilla Java project. We have this source. Inside we have a main folder, and then we have a Java folder. So this is basically where we'll write our Java classes. So this is where we'll just put our Java packages, and you will write your classes. And we have some resources folder, which is a folder which is by default into the class path. So that makes life easier if you have some properties file, for example. As you will see when you learn Spring, for example, sometimes you need to have a specific properties file or a configuration file. Then you can directly refer to the class path. If you put something here, then it's pretty easy to refer to it, because you just have to refer to the class path, and that's the parent of what you have here. And then we have a test folder, but I will discuss unit testing later, so let's not mind about this folder for the moment. We will only focus on your implementation folder, which is the source main Java folder. And probably a very important, Maven is not convention over configuration, so I'm not sure if that was a question or not. You say Maven convention over configuration. No, this is not true. So when we discuss about convention over configuration, you can refer to a tool like Spring Boot. Spring Boot can use Maven or Gradle, but the other way around is not valid. So Maven or Gradle is not necessarily conventional over configuration. So don't make a confusion on that. Okay, so Maven is just a build tool. It allows you to manage easily your dependencies. It can use parents to manage the way you modularize your application. It can use plugins that you can use on your continuous integration pipelines. It can do a lot of things. We won't discuss all of them today, but it's not in the same place with conventional over configuration. So what I will do, again, I will not detail a lot on Maven today, but I will at least take the opportunity to show you how the Maven project looks like in terms of structure and how to get a dependency with Maven. Take a look here. So you have the Java folder. This is the place where you will put your packages and Java classes. And then what's again important is that you have this file, which is the pom.xml, and the pom.xml is the place where you do your is one of the places where you configure your Maven. The other one, which is less used, is the settings XML file. But in the pom.xml, that's basically where you configure your project Maven configuration. Let's call it like this. In other words, the pom.xml is actually an abbreviation from project object model, and you name it like this because when you will learn deeper Maven, you will see that Maven actually is very much like it supports inheritance. You can think very much of the Maven configuration like of a class that can extend a parent and so on and so forth. But again, I don't want to go into a lot of details now. I just want to give you what you need for the moment for creating a project that uses JDBC. And to create a project that uses JDBC, you need a dependency. Now, I could have added this dependency in a plain Java project, but if I wanted to do that, to use a plain project, a project without a build tool, then I needed to go somewhere, download the jar file, which is the dependency myself, and then I should go somewhere in my project structure, select libraries. This can be different depending on your IDE. I can add a library from here, which is, in case of Java, most probably represented by a jar file, or you can have multiple jar files depending on how big the dependency is or how many modules does it have. So you have a lot of steps, and they might be different depending on your IDE. So Maven is much more comfortable. So that's the reason why I've chosen this. It's very, very easy to teach my students how to work with a project where dependencies are needed by teaching them first the very basics of Maven, rather than teaching them first how to use a vanilla project, which is anyway, in most of the cases, probably almost all of the cases, irrelevant nowadays, because it's very rarely probably that you will have to create a plain project and add a lot of dependencies yourself now, when we live in this age where we have build tools, great big build tools such as Maven or Gradle that we can use. When you want to add a dependency to your Maven project, the only thing you need to do is to add here in your configuration, which you see is XML. It's an XML representation. This is how Maven works. Inside you add a tag dependencies, and inside the dependencies tag you can add as many dependencies as you'd like. A dependency looks like this. So it's represented by the dependency tag, inside which you have three important characteristics: the group ID, the artifact ID, and the version. And the version is sometimes is optional. I won't discuss when now, but sometimes you might see it's missing. But in our case, in a just plain project, you need to have all three of them, like the group ID, the artifact ID, and the version. And if you search on the Maven Central repository, that's where you have tons of dependencies, and all of them are represented by the group ID, the artifact ID, and you can choose out from a specific group of versions for a certain dependency. So in our case, what we need to add is something that is called the MySQL driver. It's a JDBC driver. It's MySQL driver in my case because I'm using MySQL. But mind, if you are using Postgres, for example, you will need the different driver than I have. So you need to search for your Postgres JDBC driver. If you have Oracle, you will then have another kind of a driver. If you have MS SQL, you will use another dependency here. So this dependency you are adding is depending on which is the SQL technology you are using. Remember that I've started by showing you that I'm using MySQL. So that's why here I will be using a MySQL JDBC driver. So I actually know by heart already the dependencies. So I know the group ID is MySQL and the name of the artifact is MySQL connector Java. This is the name of the artifact for my JDBC, MySQL JDBC driver, and I've just chosen the latest version IntelliJ suggested me. But if you don't know, in case you don't know what is your JDBC dependency, because it might happen you just have to use a separate different SQL technology and then you don't know by heart, of course, the name of your JDBC driver, then you can actually just search for it on Maven Central. And I usually do something like this. I go on Google and I say MySQL JDBC driver Maven Central. And then basically I usually the first option I get is the Maven repository, which is Maven Central. And then I go here and look, you have already found it. So these are the versions. So we are now here in MySQL connector Java, and then I got precisely here, it tells you exactly what you need to write in your POM XML file. So you see it's precisely what I've written, MySQL connector Java, and then the version. So you don't need to learn by heart your dependencies. It just happens now that I know them because I'm using it very often in my classes, but you don't need to learn how the dependency is named by heart. You can anytime search it on Maven Central, you find it, and then you add it to your dependencies folder. And what I always do, you see that when I've added this here, if I'm looking in the external libraries, you will see by that I still have only the JDK 15, which is my JDK, the one I'm using, but I have nothing already downloaded by my IDE, by Maven. So usually what I recommend is once you've added your dependency, you go here and you say right click Maven and reload project, and you have such an option in any IDE. You have something similar in Eclipse, you have something similar in NetBeans. So you just press reload project, and then what will happen is that your IDE will call Maven, which will download the dependencies according to what you've written here. So in my case, if I've written, say I stated I need the MySQL connector Java, which is my MySQL JDBC driver, then automatically Maven downloaded for me a couple of jars. And again, if I wanted to do this without a Maven, then I could have gone myself, downloaded these jars and added them to my plain project. But of course that would have been more difficult and more error prone than using Maven. So that's why Maven is an easier way to do it. If you are starting with learning how to work with dependencies, I do recommend you avoid working with dependencies like libraries or frameworks in plain projects just by adding them here in your project structure, because you can do that manually. See, Maven did that for me. You can do that manually, but it's more difficult, more error prone, and you might see you might get frustrated by, for example, doing some stupid mistake and then not working. So I do avoid that just by using a nice build tool. It's much easier, trust me. At least as a student, I would do that instead of trying to rely on a plain project and adding myself my dependencies. Now, why do I need this dependency? Maybe it's already 20 minutes. I'm already speaking for 20 minutes, and I'm just telling you that I need to use Maven because I need some dependencies, but I didn't tell you why do I need these dependencies. This is really important, and of course I won't skip telling you why you need this dependency. So again, remember what we want to do now. We have a database somewhere. The database is managed by a different software, which we call the database management system. I have chosen MySQL as a technology, and I want to create my Java application that connects using something that's called JDBC. Like JDBC is basically again an abbreviation from Java Database Connectivity. So it's a set of functionalities, capabilities that allow you to connect from a Java application to a SQL database technology like MySQL in my case. And to do that, I will need to use some implementation. Now, if you take a look and with our first example, you will see I'm going to use some interfaces from JDK. So right from the JDK. Inside the JDK, you have a package that's named Java SQL. And inside that package, you have some nice interfaces and a few classes as well. And what happens is that in the JDK itself, you have no implementation for a specific technology. You won't find in your JDK any class that defines an implementation for your technology. It's no implementation for MySQL, no implementation for Postgres, no implementation for Oracle, no implementation for MS SQL, and so on and so forth. There is absolutely no implementation allowing you to connect to a specific technology. The only thing you find in the JDK is some interfaces, and if you remember, we've discussed that a few lessons ago. The interfaces, which are a very important kind of structure in Java, they represent contracts. They do abstractions. So when I'm using now, say I want it from my Java application to connect to a database, and I will create a package example1 here to show you what I'm doing, and inside a class example1, I'm going to use some interfaces from the JDK which are part of the Java SQL package. One of the most basics, and that you will find also in your OCP exam questions, is the connection interface. So connection from Java SQL, you see it here. I'm saying connection, and then I will have to create a specific connection for my application. But before discussing how you create a connection, I would like you to see that connection is an interface. It's not a class. Connection is an interface, and plenty of the structures we'll use in today's lessons are interfaces. They are contracts. Why are they contracts in the Java SQL package and not directly the implementations that allow me to work with MySQL or with Oracle? Why do I only get in the JDK interfaces and I don't get precise implementations? It's simple, because the JDK doesn't want to be dependent on your technology that you are using, and there are so many SQL technologies. I've just enumerated a few a little bit earlier. You have MySQL, you have Postgres, you have SQLite, you have Oracle, you have MS SQL, and many others. So you have so many implementations. So you cannot simply just manage versions of all your implementations inside the JDK, because that would mean if Oracle changes something, then they rely on the new version of the JDK. So they won't be able actually to add their changes until the new JDK releases, which is not possible. So each of the technologies are independent anyway, and they should be able to independently implement, correct their bugs, add new features, and so on and so forth. So how it happens now is that the JDK has only the contracts, which allows you to write your application the same way for all the technologies. So no matter which is the technology you choose, you will use the same approach, you will write it in the same way. And then the only thing that changes is the implementation itself that you are adding with this dependency. So the reason we added this dependency is because here in this library I've added here as a dependency, you have the implementations of these interfaces that you are going to use here. And this way, when you are writing your Java application, no matter if you are working with MySQL or with Oracle, you will write the code in the same way. and then you only need to give the specific dependency depending on, of course, the technology that you are using. So I have another question. Is there a relationship between JP and JDBC? Yes, the answer is yes, there is a relationship. I won't discuss it now because it's too long, and I already have a JPA playlist out there on the same channel if you wish to view it. Shortly, however, I just want to mention that JPA is a specification, and this specification is implemented in multiple fashions. Let's take one of them, which is the mostly used. Hibernate is one of the JPA implementations. A different implementation is, for example, Eclipse Link. And Hibernate uses JDBC in behind the scenes. So this is the relationship. To shortly answer your question, this is the relationship between JPA and JDBC. JPA is a specification, Hibernate is an implementation of that specification, and Hibernate uses JDBC. So that's one of the reasons I said it's good to learn JDBC, because even if you are using Hibernate, it's nice to know what's behind Hibernate. It's a good thing to know because sometimes it helps you easier understand stack traces, exception stack traces, and understand problems that you might face in your application. So that's probably the reason why the OCP certification still asks for this subject, because it's the way Java directly allows you to connect to a SQL database. So you should know that from this point of view, just because it's a basic and it will help you even if you work with a higher level abstraction like a JPA implementation. So hopefully now you understood why we needed to add this, because the JDK doesn't contain implementations for specific technologies. So now if I'm using MySQL, I will have to use a dependency for MySQL. But if I would use, for example, Oracle, then I would need to use a specific dependency that comes with all the implementations of the interfaces I'm using here, but there are for allowing me to connect to an Oracle DBMS, and so on and so forth. So remember, always remember that Java, the JDK, doesn't provide you implementations. It provides you a way to decouple from the implementations by using interfaces, by using nicely created contracts, and that allows you use your specific dependency here according to the SQL technology you wish to connect to. So that's the reason why you need this dependency here that's called again a JDBC driver. The JDBC driver comes with the specific implementations for the interfaces of the JDK that you use so that you can connect to a specific technology. In my case, I want to connect to MySQL, so I've added the JDBC driver that contains the implementations for MySQL. And with that being said, let's go into our first example. The first thing I need to do to connect to a database and be able to work with a SQL database is obtaining a connection to a database. The connection is represented by the Java SQL connection interface. The connection allows me to get further and send queries to the database, and these queries, which are SQL queries, will be interpreted and executed by my database management system. But first of all, I need to connect to the database management system, and there are three important things I need to specify when connecting. One of them is which is the database I wish to connect to, and I do that using a specific URL. The URL tells my Java application where is the database I wish to connect to, and then a set of credentials, because the database management system not only provides you a way to manage the data in your database, but it also secures your database. So like for any other server, you need to authenticate and get some privileges. So you'll be both authenticated and then authorized to do some operations. And to authenticate against a DBMS, you need to provide the username and you need to provide the password. JDBC, is it part of the JDK or is a standalone dependency? So we call JDBC, when you say JDBC, it's both what's inside the JDK as well as the drivers that you need to use. But remember that again, in the JDK, you have no implementation. There is no implementation in the JDK. In the JDK, all the classes in the Java SQL package or interfaces only represent the abstractions you use in your Java application. That's why you need to add this dependency here, which allows you to connect to a specific technology, like MySQL in my case. So this is the JDBC driver. We call it JDBC because it's a driver for the JDBC connectivity that comes with all the implementations, in my case, that I need to connect to MySQL. So in the JDK, I only have abstractions, and that's why separately I need to use a JDBC driver to connect to a specific technology. And that's why I had to use, for example, in my case, Maven today, because I need to get somehow this dependency. Okay, so I hope this is now clear. And of course, it will get much more clear while we work on the example. You will see immediately. So again, I was here where I was telling you that first thing you need to connect to a specific database management system is telling your application where is the database and telling the application who you are, and getting this way the privileges from your database management system. So this is what your application needs. And in my case, I've already started at the beginning of this lesson a DBMS, and it's a MySQL. And I connected using MySQL Workbench that, again, at the beginning of the lesson, I gave you the prerequisites. I told you need to install a DBMS and you need to install a client for the DBMS. And if you choose MySQL, you need to install MySQL, which is something you do very easily. One of the choices is installing some from Apache Friends org, and MySQL Workbench, which is the mostly used MySQL client probably. And once you connect it to your MySQL server, then you can create a database by clicking on this nice cylinder here, which is the representation of a schema, which you can just think about it as a database, your database. This is your database, okay? Don't overthink about it. You just give it a name, let's say Java. Do I have any Java database here? No. When I will apply, so you see these are my databases here. I apply, I say apply again, finish, and you can close the window now, you don't need it anymore. And you have a Java database here. You just name your database anyhow you'd like, so just name it, give it any name you'd like. But you need a database. Say I have a database now. This is my database, it's named Java. Inside I have tables, because this is the way SQL works. By the way, I do assume you have some SQL basics. You do know some things about SQL already. So I won't teach it in this course, but maybe at some point I will create a separate stream where I discuss the SQL fundamentals. But now I will assume you know some basics, like you know what a table is, and you know what a DBMS is, what a database is in terms of SQL. So I do assume you know a little bit of this. I won't teach you that in this lesson. So I will maybe do that separately in a different stream. But now as a Java developer, you need to have some basics of also about SQL. So you need to do that. So do learn some SQL as at least the fundamentals. Is JDBC NoSQL databases? No, JDBC is only for SQL databases. Any other NoSQL implementations such as Mongo, Cassandra, Neo4j, Redis, and so on and so forth, they have their own implementations. They are totally different things. Even these implementations, they work different one from the other. We won't discuss them now, but no, JDBC, when you say JDBC, we only refer to SQL, so only to SQL. Now, in the tables, just to prove you something, I will have to create my own table, and I will just right click and say create table. I will give my table a name, product, and inside the table I have to store some data. I will first make sure that I have a primary key, and in my MySQL implementation I like to make my primary key auto increment, which means I leave my DBMS to give values to this primary key, which are automatically incremented. The AI comes from auto increment. PK is primary key, which is the value identifying uniquely each record. And NN is not null, which means that, of course, the ID needs to have a value. And then I have a name, say I have a name, and say I have a price of my product. So I have a name and the price, which are the details I'd like to store in my database about the product. And in case of a SQL table, each of the attributes, each of the fields that you store, they have their own data type. So it's very similar to Java. Int is an integer. Then you have varchar, which is a string. 45 means that the string can be at most 45 characters long. And then say I want my price to be a double, which is like in Java a real number. Okay, so we apply. I apply again, and then what happens, I can actually close it now, and what it happens is that I now have a table. And if I right click on the table and select the first option, select the rows, it will show me what's inside my table now. You can see it here. So here you can see what's inside the table, and of course you have nothing here yet. So it's an empty table. Empty because of course we didn't add anything. We have just created a table. It's nothing there yet. So now I'm going to my application again. And I was here at the URL where I want to tell my Java application I want to connect to this Java database here in order to, for example, add something in the product table. So to do that, I will use an URL that says I'm going to use JDBC connectivity to a MySQL implementation on my local computer, which is represented by localhost, and then the name of the database I wish to connect to. Mind that the URL is different depending on the technology you use. So if you use Postgres, you will see that the protocol looks differently because, of course, when you connect to a Postgres database, you can't use the MySQL protocol. Likewise for Oracle, likewise for any other technology. So the URL is different depending on the technology that you use. Also, sometimes you will see people using the port here. Like in my case, I can specify the port the DBMS runs on, which you've seen is 3306. But if you use the default port of your technology, then you can leave it out. It's not mandatory to put it there as long as it's the default port. So MySQL by default runs on 3306. If you wish, you can put it there and specify the whole socket. But if you don't want, you can leave it out as long as it's the default one. Just for you to know when you see it, for example, in your OCP questions or on internet, you have to know why it's there. And then I need the username and the password. And in case you have just installed MySQL Server for Test with SAMP and you didn't write something by yourself or didn't configure something specific by yourself, then the default is root without a password. Of course, in a production-ready application, you will get a pair of credentials that's configured, and usually is the job of a database administrator to create you the pair of credentials. But if you just write an example like I'm doing here, so I'm just using the default. By the way, no password, it means no space here. Sometimes I see my students putting a space here, which is wrong. So make sure you have no space, it's just the empty string as a password by default. Of course, if you have configured your own credentials, then you will have to use your own credentials. So do use the credentials you have configured if you configured any credentials. And with this, now I'm going to get a connection. And I'm saying driver manager get connection and specifying those three parameters here. So username and password. You will see that in most cases, when working with code that connects to a JDBC, by JDBC to a SQL database, we have that nice exceptions called SQLException. This is a checked exception, And that's why in my case, you see I have a problem here because, you know, a checked exception is that kind of exception you need to treat. You need to either use a try catch to catch it and treat it. Otherwise you need to throw it out of your method. I will use a try catch here, and I will I will catch and treat this SQL exception. Let's just say it's E here. Okay, I don't do anything special now for my SQL exception. I will just catch it so I don't have a compilation problem. But you see, I need to add the try catch because SQL exception is a checked exception, so you need to treat it. Otherwise, the compiler, as you know from the exceptions chapter, it won't allow you to compile your application. So I get a connection. Usually, but we'll discuss this in the next lesson. You'll see a connection. You don't usually deal a lot with connections directly in a real world application because the connections are generally managed by an object named the data source. And the data sources are objects nicely implemented to optimize the way your application work with connections to a database. But when you will work directly with JDBC, and the code that you will see in your OCP exam uses the connection, and most likely you will see the driver manager class used the way I have used it now. The static method get connection that gets the details to connect to your database and comes back with a connection. So that's why for the moment and for our first example, I will only use it like this. Then the second thing I'd like you to know is that the connection is a resource. And if you remember, a resource is that object you need to close at the end. And if you remember, when we discussed exceptions and we discussed the try-catch structure, we discussed about the try-catch with resources, which allows you to define resources inside the round parentheses. You declare the resource like this here, and this way Java will take care of closing it at the end of the try block. And what you will see here is that I have a problem of compilation again, because when using Maven, by default, if I didn't specify anything, Maven will consider I use Java 5. And in Java 5, I don't have a try with resources because the try with resources is available starting with Java 7. And what I usually do, I'm actually doing something like this. I'm in IntelliJ, I say set language level to 7, because that automatically will add to my POM.xml file this nice configuration. And this configuration, I could have written it by hand, of course, but you see it's quite a lot of rows that I have to write. This specify which is the version of Java I use, so that, of course, IntelliJ put here the minimum version I need to use, which is 7 for my syntax, but I will just make it 15 here because that's what I'm actually using. I'm using 15. And then I will, again, I usually recommend you do a right click and reload project every time you change something in your POM.xml file when working with Maven. So now I'm actually working with Java 15. So you see, I don't have a problem anymore because, of course, Java 15 has everything what's in Java 7 and also has the possibility of writing a try with resources. Then the second step I will do is from the connection, I will create something called a statement. The statement is the command I wish to send to my DBMS. So that's represented in JDBC by the statement interface in Java SQL. And you can get an implementation of the statement interface by calling the create statement method of the connection. So when you call this here, because I have added the MySQL dependency, I will get a connection specifically for my MySQL DBMS. And then, of course, that one will know to give me a statement implementation that's, again, according to the technology we use, which is MySQL. And you see that I've written the statement still in the resources part of the try-catch because the statement is also a resource. And now that I have a statement, I can actually use one of the three execute update, and execute query methods that I will detail in the next lesson. So we have 3 methods. Again, I will detail them in the next lesson. It's execute update, and execute query. And with one of these methods, you can send a query, a SQL query, to the DBMS, to your database management system. So I'm using execute update, which is the, as we'll discuss in the next lesson, execute update is the method you can, is the method you can use for insert, update, or delete queries. And in my case, I will write here an insert query which will just create a row in my table. So I say insert into product. So I'm connected to the Java database, and now I'm inserting into the product table. Remember, it's the name of the table we have created in our Java database here. So here is where I want to add something. So I say insert into product, values, and then I can say null for the ID, because the ID was created as auto increment, which means that the DBMS will give a value for it. And then I say beer, because I'd like to drink a beer now, and then the price, which is say 5, whatever that is, doesn't matter. And this query is what tells my DBMS to insert in the product table a new record with the values I've provided here. Automatically, my DBMS will give a value to the ID. That's why I don't have to send a value here, because I marked it at the beginning as auto increment if you've been attentive to my actions. And then the name will be beer, the price will be 5. And now I'm just pressing run, and I'm running this example. I'm waiting a little bit for my application to be built and run. And you see that everything ended, so my application ran correctly and I have no exception. If you have written your code correctly, that will be your result as well. And then I'm going here in my MySQL Workbench, and I'm selecting again by pressing this button. I will just rerun this statement, which will select all the records. And you will see that a new record, a new row appeared here out of the sudden, which is precisely the record we've been adding from our application. And if I'm running my application again, a new record will be added and the ID will take the next value. Of course, I didn't change anything here, which means that the name and the price of the product will be the same. If I run it again, you see that another product has been added. So the new ID is 2, which is auto incremented, which is provided by the DBMS. And then the name and the price is the same. And then if I run it again, then that will happen again and again and again. So you will always get a new ID and a new record will be added with whatever you specify here. So that's our very first example with working with JDBC application. Now, what I want you to take from this lesson is, first of all, the very basics of using dependencies with Maven. I want you to learn how to create your first Maven project and how to declare a dependency. So you've seen here what the project structure for a Maven project is and how you add a dependency. And remember, we need to do that because when working with JDBC, you need to add the implementations according to your technology somehow. So you can of course do that manually in a project, but the easiest way is to actually use a build tool and make use of your build tool to manage your dependencies, like I've done here to add my JDBC driver for MySQL. And then I would like you to remember how the JDBC architecture looks like. Very important to remember that the JDK doesn't contain an implementation. You will only find the contracts here. That's the reason that's how your Java application is independent to the technology you use, because you see, the only different things I'm using according to the technology is the driver. Of course, you will have to add your specific libraries to your class path according to your DBMS, and the properties here, like the URL, will be different if you use Postgres. But when you write a code, is the same Java code you would run for Postgres as well. And of course, one of the things that might be different is the SQL as well, because you will see that the very basics of SQL, they are based on a standard that's called the SQL 92. But in case of every specific technology, the queries, they have something common, but they have also there's also a possibility that they are different from a technology to another. So you'll see that there are specific things that you can, for example, only do in MySQL, or you can do only in Oracle. So of course, if you use some specific query that works only with Oracle, that would need to be changed as well in case you decide to use a separate technology. But the Java code will still use connection, you will still use statement, will still use execute update. The Java code is the same no matter which is the DBMS you are using in terms of JDBC. And the reason it works like that is because here, as you see, you only use contracts. That's the value of contracts, that's the value of abstraction. That's why we focused a lot in the previous lessons on interfaces, and you've learned what interfaces are, because these allow you the great capability of decoupling your code from a specific implementation. And that allows you have a specific code that's the same no matter which is the implementation you choose afterwards. And that brings you great value to your application, because otherwise, if we didn't have that, you would have needed to learn some specific code you need to write for Oracle, some specific code you need to write for MySQL, some specific code you need to write for Postgres. And that would have been awful, isn't it? Because you'd have to learn 5 times more things than learning only one way of writing code that works with any technology, and learning that the only thing you need to work different, to do different, is adding a specific implementation. So you actually work with the abstraction, with the contracts, and then the only thing you need to do is just add a different dependency, which is pretty cool, isn't it? So thank you very much for watching this lesson. I will share, of course, as usual, my project, and I hope you will take the opportunity of creating it yourself and try it, of course, try it yourself and rewrite it yourself. And this is not everything. We will have to continue in the next lessons, where we'll discuss a lot more things. We have to discuss about how to select data, how to use prepare statements that are also in your OCP exam, and many more other things in this chapter. So thank you for all your questions and for being here. And for now, have a great time for study, and see you for the next lesson.